Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Well, it's tax-deductible to the extent allowed by law. The new tax law makes it more difficult for donations to be tax-deductible, so you'll have to check, but any help is welcome. Here's a problem for today for exam P. X is a normal random variable with mean 0 and variance 1/2, and Y is distributed exponentially with mean 1. X and Y are independent. Find the probability that X is more than Y squared. And we have 5 answer choices. And here's the solution. Well, from what we know about X having a normal distribution, the density of it is 1 over square root of 1/2, which is sigma, times square root of 2 pi, times e to the minus 1/2 x over the square root of 1/2 and the whole thing squared. The mean is 0 and variance is 1/2, so that the standard deviation is the square root of 1/2. And then once you cancel things out, this is simply 1 over square root of pi times e to the minus x squared for x between negative infinity and plus infinity. And f sub y of y, exponential, is with mean 1, so hazard rate 1 as well, is e to the minus y for y positive. So that the joint density, they're independent, so we can just multiply the densities, is 1 over square root of pi times e to the minus x squared times e to the minus y for x between minus infinity and plus infinity and positive y. What is the probability that y is greater than x squared? Well, it's the integral over the region where y is more than x squared of the joint density. So that's the integral from minus infinity to plus infinity, the possible values of x. And then for a fixed x, we only take a y that is greater than x squared, so we go from x squared to plus infinity. And then the product of the two densities, which is 1 over square root of pi e to the minus x squared times e to the minus y dy dx. We do the integral with respect to y first, from x squared to plus infinity. Well, 1 over square root of pi is just a constant. We put it in front. That becomes then integral from minus infinity to plus infinity of e to the minus x squared times, and notice that the integral of the density of y from x squared to plus infinity is just the survival function of y evaluated at x squared. And what is that for exponential distribution with mean 1? Well, it's e to the minus whatever number we're evaluating the survival function at, so in this case it's e to the minus x squared. So this whole thing becomes 1 over square root of pi times the integral from minus infinity to plus infinity of e to the minus x squared times e to the minus x squared. And that's 1 over square root of 2 pi times the integral from minus infinity to plus infinity of e to the minus 2x squared dx. And when we rearrange it a little bit and write it as square root of 2 times 1/2 times the integral from minus infinity to plus infinity of 1/2 times square root of 2 pi. So you see that square root of 2 and the square root of 2 in front cancel out, and it leaves just 1 over square root of pi, and then 1/2 in front and this 1/2 cancel out. So that's why those two are the same. And then we write the e to the minus 2x squared as e to the minus 1/2 times x over 1/2, the whole thing squared. Well, that's actually now the integral of probability density function of a normal distribution with mean 0 and variance 1/2 squared. So it's a little bit different than the one we had before when it was variance 1/2, but that's just how it works. Okay, what is the integral of density from minus infinity to plus infinity over all possible values? That's equal to 1. So this expression is equal to square root of 2 times 1/2 times 1. And that's square root of 2 over 2, which is answer E. Please remember this is copyrighted material. The problem was written by me, and the solution is mine. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited.